So we are going to discuss today about evaluation and optimizations for the AI agents. And before that, I just wanted to give you give you all a bit. Uh, Anyone who has questions, you can feel free to put those questions in the chat instead of. I mean, I will definitely have some time for us to to discuss. So after every few slides, I'll give you a pause and then you can ask any questions. But if you, in the meanwhile, if you have questions, please drop it in the chat. Um, and we will have a discussion after the presentation is done. I don't know how many of you are already aware of a large language model. Um, I mean, uh, I do know that there are a lot of ChatGPT is which everyone is aware of, is a product powered by a large language model called GPT 3.5 or 4. There are a lot of new versions are coming up. The recent version is O3, which just came out like a week ago. And we also have O1, which is a reasoning model. And prior to that, we have GPT-4, GPT-4 Omni. So these are different large language models. So what happened in 2022 is basically we were able to create a large language model that can do reasoning. So it's really very first time in I can say in all of our humanity where we could actually build a system that does reasoning. So that really makes AI stand out, and that's the reason why you see a lot of this noise about AI now. Even though there's a lot of research which are already going on since like 2012, 2013, 2016, 2017 is where transformers were actually got created at Google, which is the basic or the T that stands for GPT, which is transformer, which is the basis of all the current research. So basically, they do text generation, summarization, translations of the BERT model, which was previously used by Google for do a lot of translation. So Google actually have got transformers to solve translation problem, one language to the other language. But transformers are so beautiful at generalizing things. So that form basis for our GPTs now, which is generative pre-trained transformer. A lot of applications with large language models. There's chatbots, content creation, code generation, data analysis. And I know a lot of data analysts out there. They want to do data analysis now, but these models are evolving so well that you definitely have to partner with an LLM to be a more efficient data analyst. So yeah, it's really exciting times, by the way. It can handle pretty complex language tasks. Reasoning and planning abilities, they do have inherently do that. As of now, the claim for the O3 model that just came out is PhD level cognition. O1 is also they're saying it has PhD level cognition because the reasoning power is definitely growing for these models. Challenge is definitely resource intensive. So every call to Google actually it actually 10 times more expensive. A ChatGPT call is 10 times more expensive than a simple Google call. So a small question that you ask Google, or a small question that you ask to ChatGPT, it's 10 times more energy intensive than Google. So they are resource intensive and they are prone to biases because large language models are actually trained on all of internet data, and internet data is not clean, by the way. It does have a lot of data which is not supposed to be there or not supposed to be good for different use cases. So there are a lot of biases too. Most of the internet data is biased towards a specific category or a specific community. So definitely there are challenges with these large language models, and knowledge cutoff is a problem. I mean, knowledge cutoff because of we can't continuously train a large language model. A GPT-4o model, probably the knowledge cutoff is April, so it would not know anything about the recent information. If you go and ask ChatGPT what happened yesterday, or maybe a current today's news, it may not give you that on the fly unless it has access to internet. ChatGPT now also provides access where you could click on internet button that can give access to internet, where it can pull data and then let you know if about the latest news today. But inherently, these models have a knowledge cutoff problem. They're not continuously trained. They're only trained to a certain point in time. So I think the latest model is only trained till April of this year. Um, and I mean, ChatGPT. I keep saying ChatGPT because most of you are already familiar with it, but it's not the only model, or it's not the only product out there. You still have, GPT-4 is a model that's powering ChatGPT, but you also have Llama from Meta, which is an open source model. You also have Palm from Google. You have Cloud from Anthropic, which is actually AWS or Amazon has a lot of stake in it. Mistral is a great model, which is also open source. There's a lot of open source and closed community or closed source models. So, yeah, ChatGPT is not the only one out there. But LLMs actually form the basis of these AI agents, or whatever we're going to talk about. That's the reason why I'm just giving you a bit more basics about what it is. Um, um, so why do we need AI agents when we already have LLMs, right? We already have ChatGPT. Then why are we talking about AI agents? So basically, the things that we want to accomplish with, maybe we want to be more productive in any of our workflows, internal workflows. It could be, something to do with improving our own IT operations. It could also be something planning our own personal, vacations, or something that can make us a better data scientist or maybe a better in manager. So the ChatGPT already has, or a model like GPT or this large language model has reasoning power. They can perform planning too, but how can you make use of them, right? You could have ChatGPT, if in case you want to integrate your own database to ChatGPT, it's not possible because it's a general product that anyone can use, but you could still access it through an API. You could still make use of the planning and also give it ability to do an autonomous work, a multi-step actions to perform a specific task. Maybe it could be booking a flight ticket for you, or it could also be, planning out a project for you, or it could also be, just going out there and probably, doing some data analysis work for you. So there could be a lot of things that you could probably need. And AI agents are basically wrappers around these LLMs, which are making use of the large language model cognition or reasoning power to perform a specific action. So that is what they are. They just if you are coming from IT background, you have an automated script, maybe a Python script to do a simple automation, but those are all rule based, right? Something changes, then they break. But LLMs are more cognition driven, so they're not as brittle as a Python script. They can understand images because they're multimodal. They can understand audio, they can understand videos, they can understand text. So they are going multimodal. So they can actually go ahead and use your computer to do a specific action, because in the recent computer use tools that Anthropic Cloud came up with, or even Gemini recently, you can screen share and you can ask model to help you out navigate a specific task, and it will still help you out with it, because these models can be best trainers, or they could also be your co-pilots to do a specific task in an automated fashion. But they are not perfect. These are something which are just going, which can definitely help things happen. But we'll definitely discuss about some issues with it. But with LLMs, by giving access to them through tools, APIs, they can execute, implement complex workflows. They can retrieve data, they automate processes. Scalability is definitely there. You can make them repetitive. You could also transform these LLMs, to solve various problems, decision making. And recently, LLMs are also being, these AI agents are also being developed or crafted as research agents. They're doing more research, a PhD doing his own independent research. You could have an AI agent as a co-pilot for that PhD to scale his research, to scale his cognitive abilities to perform more, and to achieve a lot more. There are people inventing new materials, which would probably take years and years, but now they are able to do that very faster by crafting their own AI agents. So if someone want to pursue PhD, AI agents is something that you should be a basic skill that you should possess, because you could actually craft your agent to do your own research and expedite your research process. AI agents or LLMs would definitely replace someone who's not using them. So definitely that's going to be there. I mean, it's not going to replace everyone, but definitely people who are ignoring it, they might be replaced because someone might be running with that. It can scale abilities or make them more productive than others who are not using it. So I mean, it is general. So everyone who are working in any domain, I think we all will have our own digital colleagues who are working alongside with us to make us more productive and also improve work-life balance. I mean, that's what I'm hoping for. Hoping for. I mean, I'm not sure. It's still, uncertain, but yeah. Um, so let's go ahead with understanding what is this AI agent and what are the different components of these AI agents are. So I want to just divide this AI agent into four categories. I mean, different components of this AI agent into different categories. AI agent should have access to tools. I mean, in order to perform a specific action, any action that has to perform, it could be calculating something, going ahead and booking a ticket for you, helping you navigate through your files. Any action, it requires a tool to perform that action. Imagine these to be your hands, or it could also be, APIs. It could also be a web browser where you go ahead and click buttons to do something. It could be a calendar, a calculator, a IDE. It could be a search. So it could be anything. All of these could be different tools that we usually use to navigate through the digital world or to do something. You could actually make an AI agent control that. We were 2 or 3 months ago, we were only talking about APIs, a database, and things like that. But now you could even have this control your laptop and your computer too. So that could itself be a tool for your agent. So this is what a tool actually means for an agent. So that's a very critical part to perform a specific action. You should have a tool, and tools could be different kinds. They could be, they could also be a planning, which is important. Agent has
Hello.
to plan.
Hello.
Yeah,
Hello.
Indrajit.
Yeah, my name is Indrajit. I just want to say, like AI agent, you want to mean that it is a robotic robot, similar to
Uh,
robot?
yes. So yeah, thank you, Indrajit. I mean, that's good. So if you're coming from the robotic world, say there are a few things. Okay, AI agent is a broader term. So here, whatever AI agent that we are talking about is large language model powered AI agent. But they could also be AI agents in robotics too. Example, it could also be a AI agent that is deployed within a vacuum cleaner that perceive, if you see the one of the initial things which I put here is perceiving, deciding, and acting. So this is more of a generic thing. So it could also be applied to robotics, where a robot can perceive something. It can, it can use to act on it. Maybe it could be actuators or motors. Let's say a EV or a robotic or self-autonomous vehicle. It can perceive data through its cameras to see if there's an obstacle, and then take action by directing or sending signals to a motor to turn left or right. So that could also be an AI agent too. So AI agent is more of a generic term. It could not just be, I mean, here, whatever we're discussing now for this session is large language model powered AI agent. So this is basically automating all of the digital operations, which is completely digitized. And you would also have embodied AI that probably, Indrajit, I'm not sure which background you're from, but if you're coming from embodied AI is also robotic arm that could also have an AI agent within it, where you have reinforcement learning powered AI agent, which can actually go ahead and perceive a robotic arm can just place things or you can move things by perceiving different actions. So that itself also be an AI agent, but that is more in the physical domain. So yeah, Indrajit, I mean, yeah, whatever we're discussing is LLM powered. So Indrajit, where are you from? What background do you have? Like, are you from software or hardware background?
I am from software development and
So development.
mostly
Okay,
working on the cloud technology and using AI.
absolutely. Okay. Yes, Indrajit. I mean, yeah. So AI agent here is actually LLM powered AI agent. It's not hardware. But if someone is coming here in the call from industrial technology, robotics, electronics, embodied systems or embedded systems, I mean, they also have something called AI agent. But it's the basic operation, it's the same thing. There, the deciding factor is perception happens to computer vision, and the action happens by sending a signal to motors or something. But that is driven in the physical world, and here it is basically an automated thing. So imagine this to be something like a tool. Maybe you have your cloud environment, right? You work with cloud, so you have your cloud environment. You could have an AI agent that just goes out, probably performs read through your cloud billing and probably go ahead and turns off some EC2 instances. The tools here could be some scripts, right? You could have a script to spin off your or spin down your EC2s or anything like that. So AI agent can perceive the data through a API call to your cloud APIs to check the billing and go ahead and turn it off. So, I mean, that could be one of the examples which I can. I mean, it could also be done through a script, but I'm just giving you a generic example on how we can use AI agents. I mean, we are developing some SRE agents, so which does root cause analysis too. Let's say a service went down, it can just go get information from Datadog to analyze how the service went down, see the error code, does some planning on what could be the reason, use kubectl to get more logs, and then act on it. So we are working on something like that. But these are also some kind of AI agents which will help cloud engineers like you to perform root cause analysis and things like that.
Yeah,
Hopefully, I'm making sense.
Yeah.
Yeah, thank you.
Sure.
Ranjit here. So
Yeah, Ranjit.
I'm going to discuss here RAG, agentic AI implementation. RAG, okay, generative AI has, if you add agentic AI, there's a RAG agentic AI implementation actually.
Yes.
So, and there is a adaptive RAG also, which is again
Yes.
one versus above than the agentic AI. So are we going
Yes.
to cover those things in this discussions today?
No, Ranjit, we already had a previous session on RAG. I think it was a couple of months ago. So this session is only around evaluations and benchmarking. So we'll be talking about how are we going to evaluate our AI agent. It could also be RAG. I mean, RAG is basically, retrieval augmented generation. RAG would also have to be fine-tuned. So a lot of these things what will be discussed would also be applied for RAG because AI agent would need access to memory and all, and it requires a vector database where it stores all of that. So, but we are not directly discussing about RAG. We'll not be like, oh, we are only optimizing for RAG. I mean, agentic RAG is similar to this. Agentic RAG is actually doing the same thing, right? It has a tool. It just goes and it retrieves some information. It does a self-reflection of the retrieval and go back and optimize that. So that is what an agentic RAG is. So same thing here. But it could be applied not just for RAG, but it could also be applied for different domains like travel booking or helping other domains as well. So it's more of a generic concept, I can say. But all of those apply to even RAG or even other things as well. Yeah, but we're not specifically discussing about RAG. But it's just agentic RAG is almost the same concept.
Hi Raj, Mahesh here.
Yeah, Mahesh.
So regarding this AI agent, so can you please explain us where this agent will fit into the Azure AI services and external services we will be using and different tools? I mean the architecture wise. If we have to place agent, where we will place?
So Microsoft or Azure already has a framework called Autogen. So that is from Microsoft. Yes, okay. It's called Autogen. So you could actually use Autogen, and tool could be anything. I mean, it could be any of your Azure APIs too, right? Azure has a lot of APIs. Are you a developer, Mahesh?
Yeah, I'm a developer.
Okay, you're a developer. So let's say you have your cloud, maybe you have Cosmos DB, right? You want an agent to check if any of your maybe you have maybe someone is chatting and they want to check if that customer is cancel the service or not. So you could have this AI agent or something. Autogen could also be a framework which is from Microsoft, which will have access to Cosmos DBs through an API. So when you chat with it, you can ask it, hey, can you check if the customer canceled the service or not? So it can just go ahead and execute a query into Cosmos DBs and get back a result and tell us how, he's already there or not. I mean, you could also do the same thing, but what's happening here is it could actually be done through an AI agent. It could actually be done by a function call, or it could also be done by external tools. The tool here could be an API call too, or it could also be Cosmos DBs directly. Like it could be using a JDBC to just go ahead and get some information from there, or it could be any of the sort. So it could be made cloud native, which is what I'm saying. So the tools here could be any of the APIs. Yeah, go ahead.
Is this different than the Power Apps or semantic kernel?
Power Apps, semantic kernel is almost similar. I mean, semantic kernel is also the way to build agents. Power Apps is different because Power Apps is more of like, is a no-code tool to build simple apps, right? That is what Power Apps is.
Okay.
Right. So it's a bit different than Power Apps because they have some standalone inbuilt templates in Power Apps. So that's a bit different. Whereas,
Okay.
but it
So
can
for
be
create-
related to semantic kernel. Yeah.
Okay. So for creating agent, which one we should prefer, AutoGen or semantic kernel?
I mean, I would recommend AutoGen. Semantic kernel
AutoGen.
could be
Okay.
integrated. It could be a component for AutoGen. So
Okay.
semantic kernel is more of like it's basically a SDK, right, to deal with LLMs and all. But it's more of a it has connectors to interact with a lot of Azure APIs or prompt functions. You also have different skills that they have given or plugins. So it's similar. So it already has out of the box features to interact with different things. So you can build an agent with just semantic kernel, or AutoGen also provides more robust tools as well. So AutoGen already has semantic kernel integrated with it. So I think AG2 is one more service that that Microsoft came up with. It's called AG2. I think that has semantic. Yeah, it's called AG2. So they're dividing AutoGen into two different things now. So they are using AutoGen as one research area, and they're also doing something called AG2, which is more autonomous project that they are dealing with. Both are open source. I mean, they say it's not even suitable for prod now because they're developing it as a prod. They're developing it as more of like a research project. But I am a fan of I use LangGraph. We use LangGraph. So LangGraph is better in terms of building, and people are already using LangGraph in production. So we don't use AutoGen as much, but I definitely love AutoGen because it's from Microsoft, and it's definitely active research team that's working on the development of it. But they themselves say not to use it in production, so that's the reason I'm not too confident. So LangGraph is something that we could use. I mean, we already had this discussion last time. I mean, we had a session a couple of weeks ago where we were discussing all different frameworks to evaluate agents and which framework to use for building AI agents.
Maybe I missed that. Can we get the recordings of previous sessions?
Yes, Shivani, can you please help with that?
Yes, I'll be helping with that.
Sure.
It's Mahesh, right? Okay.
Yeah.
Yes.
Raj, I think Kamakshi is asking you to shed some light on the tools regarding AI agents. Can you answer that as well?
Tools on AI agents. So I mean, tools on AI agents. Oh, can I see that?
It's from Kamakshi.
Kamakshi. I don't see that here. But yeah. So basically, tools basically means anything, a specific action need to be done. Let's say, I don't know your background, Kamakshi. I mean, can you tell what is your background? So that I can give you an example related to that. Can Kamakshi talk? Okay, Kamakshi, I mean,
can I add one more question on AI?
Yes, sir. Go ahead. Yeah.
So, are we going to discuss anything about reinforcement learning algorithms while building an agent?
No, we don't, but we will have a session in February where we are working on reinforcement learning, optimized or reinforcement learning, fine-tuned LLMs. So we are not talking anything about reinforcement learning here because that is more in the alignment space of LLMs, reinforcement learning. As of now, we are not doing that. Yeah. So, yeah.
Sorry. So Kamakshi is saying she's a Java developer. I believe she's unable to talk.
Sure, no problem. Yeah, so Kamakshi, imagine, since you're a Java developer, imagine that you're trying to connect maybe, in Java, there are microservices, right? Every service, does a specific action, maybe going ahead and adding something to the database or retrieving something, adding something to the queue. So all of these are, you could, if in your space, maybe if you're building an AI agent for a specific domain, a tool could be something like a call to a service, maybe an API call to a specific service, or it could be a call to a database. Why are you doing it? Because AI agent can do autonomous work to pull information, to gather information. It could also add data to your vector DBs and all of it. So yeah, that could be a tool. I'm just giving you an example, and because since you're a developer, I'm just giving those examples. So that could be a tool. Maybe you can have an AI agent that can plan your trip. Probably in order to do that, it has to go ahead and pull information about your flight. So in order to do that, it has to make a call to an API to get your flight details. So that call to an API could be that API itself could be a tool for it. So that just goes out and asks for a specific API. With probably it sends all of the metadata to that API. So imagine in your Java, you have to build all of the parameters to that function to get the data. But these LLMs have something called function calling. So with function calling, you can actually just send a JSON to that specific endpoint. You don't have to, and you can directly build a JSON. Your LLM only responds with that JSON to that API. You don't have to again build that or parse that response or construct that JSON and send it to it. Rather, directly build that and then does it. So inherently, these LLMs, especially LLMs which are closed source like OpenAI or all this Anthropic, they come with a feature called function calling. I'm not sure how many of you are aware of it, but it's a great feature. You don't have to write different code for it. It just does a call to a function just directly by constructing that JSON. So yeah, hopefully that answers your question, Kamakshi. If not, we can definitely shoot a message here later on. We can discuss.
So she said she got it.
Absolutely.
Also, some of the participants are asking if you could answer the questions towards the end, not to
Sure.
to avoid breaking the flow.
Yes, absolutely. Let me do that. So let me just go through this, and later on we'll have a discussion session. So please, guys, I think definitely
You all
we'll
can
go through
post
that.
your questions, team. So
Yes.
if there's anything, we'll answer towards the end.
Absolutely. Thank you, Shivani. Thanks for organizing this. So there is a planning module. There is action. Action is a series of actions that it has to take to achieve specific thing. And planning has different planning things. Like it has reflection, chain of thought, sub-goal decomposition. So these are different kind of planning. Just like when you want to plan maybe a big trip or maybe to do a specific function, you usually divide that huge task into small chunks of tasks and then work on it. And you can't just go build a huge app at once, right? You still have to break that app into, one day have to develop front end, one day have to do back end, then have to develop these integrations and all of it. So you need to change that. You have to basically break it down into smaller tasks and then work on that individually. So that is what the planning task actually planning takes care of. And LLMs are inherently good at planning, and we'll be evaluating all these parts of agent. So that is what we're trying to do now. So this is basically giving you an introduction of what component that AI agent has. And then from the next slides, we'll be going into different parts of these AI agents. How are we going to evaluate that? Because inherently LLMs are not 100% right. I mean, when you write a code to go ahead and write your data to a database, that code will work 100% of the time. It will just go and put that data into database. But LLMs are not like that. They hallucinate and they fail. They tend to generate different stuff, or they fail to call the right tool. So we are going to discuss that. How are we going to evaluate it? How are we making our agent more consistent? That is because inherently LLMs are a probabilistic machines. They are deterministic. So they are non-deterministic, not like our code that we write. When we write our code, we write all of our applications are deterministic. When you add some CRUD operations, create update, it does updates. But here it is not the case. Your agent might call it, may not call it. It might not do proper planning, or it may just fool you. There are a lot of things that the LLMs could do. So how are we going to evaluate it? How are we going to benchmark it? That's what we're going to discuss now. But overall, I just want you guys to understand what are different components, so that going forward in the next discussion, you understand all these parts. And what is memory? Memory usually being, just like how we remember a lot of our previous actions. If you're a developer, you should remember, okay, what is your product about? What does your product do? All of those, that has to be part of your long-term memory. If you're using an agent for, maybe a developer, or you're using an agent for a travel agent, and it should know long-term, what is your age, what are your interests, what is your citizenship. All of these data, the metadata about you, should be probably persistent and should be part of the long-term memory. Short-term memory could be something that is happening right now while booking. Maybe you want a vegetarian meal for this flight, so it has to remember for that flight duration that you are booking, it should remember that information, that your preference is vegetarian or non-vegetarian. So that could be part of your short-term memory. So these both makes memory as part of, imagine this almost like creating a human brain. Like memory, you have tools, you have planning and action. So you're building a brain, or maybe a digital colleague. So yeah, let's evaluate for AI agents. Okay, what are the things that can go wrong? We know agent has tools, so it can call different tools. So tools are nothing but these tools are inherently, you can call different functions to perform an action. A tool could be calling a calendar, calculator, search. It could be a lot of things. So if you see here, the tool calling is something, it is not done 100% of the time. When you ask your agent to, when your agent has to go ahead and book a flight for you, it can go ahead and call a specific API and to book your trip, because it has to go ahead and get flight data. So it might call the flight data API. And it is doing right now, but if you ask it 100 times to do the same thing, it might not do 100 times the same exact thing. It might hallucinate sometimes. It might fail to do it. It might not call that API. It might just say the flight exists, or it might create some data. So we need to evaluate for it. When you build a tool call, when you have your agent that is calling a specific tool, you need to make sure that is there. And also, agent also have some issue called implicit action recognition. So what is it? So let's say your agent has to go ahead and write a file. Maybe your agent is helping you with coding. It has to go ahead and update a specific file, but it will just go and try to update it. But it has to make sure the file exists. Without exist, if the file doesn't exist, it cannot just go and update, right? So the challenge with tool calling is it will just go ahead and just try to update it and it fails because the file doesn't exist. So this is the implicit action recognition. You should know implicitly that whether there are prerequisites to perform that action is already done or not, whether that file exists or not, whether that API that you're calling has all the parameters needed for it or not. Otherwise, your tool calling would fail. So, and also managing system states and parallel operations, because, when you're trying to do this tool calling, and let's say you have, you called a API for your flight, and then now you have to go and book your rental car, and now you have to go ahead and book your hotel. So it should, and maybe, there's some issue happened and you came back after a couple of days, you stopped at, rental cars, and now you have to go ahead and book your hotel. It should not just go ahead and restart all of it again. It should actually maintain its state. So you need to even evaluate your agent. Does it maintain the state? Even if you come back, or if the system fails, maybe, it restarted, maybe the server restarted, whether the agent can actually maintain that state or not, right? Otherwise, it will be repeating all over again. It will be more of like an ad hoc agent. It is not maintaining its state. So there are different frameworks, that are there to evaluate this. Okay, one of it is called BFCL. It's actually Berkeley's function calling leaderboard. So, so it's from Berkeley, and they call it function calling because tool calling or function calling is the same thing, because they usually say it's called function calling because, end of the day, these models, LLMs, are good at directly calling the function. So if you have an API to call a weather, maybe to get information about a weather at a specific city, one way to do that is you write code or you build that API. To build that API or to build a JSON response to it, you probably need to construct all of the function. And then you need to go ahead, or you need to include that in your prompt saying, hey, you need to go ahead and have this function and use this function. But these LLMs inherently are trained to do that efficiently. So they could directly go ahead and call the function. They could directly produce the JSON that is needed for that function. So they are good at it now, as of now, most of the advanced models. So, and Berkeley, they created a leaderboard to evaluate how good are these different models and what is the accuracy to do that function call. So if you see here, overall accuracy is 67% only. That is for GPT-4 Turbo. This is the cost for like 1,000 runs. So they're basically doing 1,000 function calls. 1,000 times they're calling it a specific function. It could be any function. And they are trying to assess what is the accuracy, overall accuracy. So the things they're measuring here is the response time, the latency. I mean, how fast your model can come back and say, give the response to it. There is something called AST summary, which is basically a syntax tree, abstract syntax tree. And non-live and live is different, because non-live is when you're running in batch and live is when you're doing in real time. And then you have a hallucination measure, which is 83.69 relevance, means whether the response or the function call that you're doing, is it right or is it hallucinating? So out of 100, it's only 83.69% times it is actually relevant. Sometimes it is not. So you're seeing it, right? So these function calls that when LLMs are driving this automation, they tend to fail. They inherently tend to fail. So that is the biggest problem that these LLMs have. They are really uncertain. They're undeterministic. At 67.28, and you see all this measure here. So this is the accuracy that comes up, and these are just for the LLM. It's not an agent, but the LLMs are powering the agent. So these are for every agent. This is what's happening, and there's also multi-turn and single turn. If you see, this is a single turn, and this is multi-turn. Multi-turn is multiple times if you have back and forth conversation. And how it is performing during multi-turn. Single turn is, okay, directly asking a question and is it getting a response or not, without multiple back and forth conversations. So that is what the difference is here. So this is what BFCL leaderboard is. And this will really help us in deciding the model that you could use and how would you evaluate your model. Because if you're using GPT-4 for your domain, it's 67.54 is the accuracy, overall accuracy that you would get. And you could make it even more accurate by creating different guardrails and all. But we're not discussing anything related to design yet. We are just discussing evaluation for the session. And there is also something called Tau Bench. It's from a recent research. So what Tau Bench does is, let's say you have your AI agent that is your travel agent. So in order to see how well it is actually doing this, how well it is interacting with your API, you simulate different conversations. So you don't have to, let's say you have your agent, and usually these agents have more of like a chat bot, like a chat interface. Like you could chat with it. You can say, hey, can you go ahead and book me this flight? You can simulate dynamic conversations instead of every human. Instead of like you can have like one or two people testing it out, you could create lot of simulated data. Like you could create you can simulate a user actions. How can you do that? Again, LLMs could do it. LLMs are really good at simulating or at least developing synthetic data like user actions. Maybe you can create like 1,000 users, each user asking about a trip to different destinations. Maybe Bengaluru to Hyderabad, or maybe US to some other place. So you could create different users have their own queries and simulate that interaction, and then have the agent talk to that user. And then what you're doing here is you're simulating these dynamic conversations, and you're benchmarking, you're seeing how your agent is performing out of thousands of interactions. You don't have to put it out in the prod and then test it out. You could actually do it before that. You can benchmark it, before going, just like how you test your code. You have your code and there's unit tests for your code, right? And what is your code coverage before going, okay, code coverage is 20%, maybe, there's 80% of your code is not covered by unit tests. So there's a lot of buggy code, right? So similar here. So you're basically simulating all of these interactions, and then you have this agent use these API tools, and any of the policy guidelines is nothing but system prompt means you have a policy saying that your LLM should know about your travel agent. So when you build your agent, you're basically crafting your agent. You're telling that, hey, this agent is a travel agent. This agent has to book trips. This agent has access to this API. So you're basically giving all these guardrails, and you're saying, okay, users cannot have, you could only do the booking by, there could be round trip or one-way trip. So you could put some guidelines in there, some rules on how this booking has to go. It's all plain English. It's just prompt that is crafting your agent, right? So you could simulate all this and evaluate the agent performance. So how are you evaluating it? Okay, let's say you have this travel agent, and that has to go ahead and book a flight ticket for you. So once the booking is done, you have a database that will just go ahead and say, okay, the booking is confirmed, right? So, but what if you have the travel agent, but out of 1,000 users you simulated, maybe almost 40 to almost 400 users, you go and look in the database, because the agent itself is going and updating the database that the booking is confirmed or not. And now you go and check if 400 users, it is not confirmed. So something might have happened. Maybe your agent is not calling the right function. Maybe your agent failed to abide by your policy guidelines, or maybe it is hallucinating. Maybe it is going back and forth. It is just burning your tokens, but not giving or actually not doing the actual work that you have put it to do. And you're also checking it for different over different trials, right? So this is what the metric is called cascade metric. So the database change state comparison is basically whether the booking is done or not, that you're just checking the database. You create a database, and the database would, you tell your agent to just go ahead and update the database whether the booking is done, or maybe you could just go and see in the backend if the booking is done or not, right? Just like how all of these human travel agents are doing the booking. End of the day, you check your database if that booking is done or not. Same like you're evaluating them, you're evaluating your AI agent. And this pass K metric is nothing but out of how many trials, let's say you repeat the same thing over and over again, and is it able to do it again? Is it able to book it repeatedly, right? Let's say you're booking a flight ticket to Hyderabad to Bengaluru. So are you able to do that maybe 10 times again and again, or you're failing at a certain point, right? So over multiple trials, you're assessing it. So that's what pass K metric is. It's one of the evaluation metric that came out with, in some of the research papers. But yeah, so even state-of-the-art agents, they could only succeed in less than 50% of tasks. So, there are a lot of agents people build outside, but they're very cool agents. They get to do this, that, but end of the day, what is the reliability? What is the accuracy, right? That actually matters a lot more. Are they, and you see a pass 8K is less than 25 in retail, means let's say if you're trying to create an AI agent to go ahead and do online shopping for you in the retail sector, it's just less than 25, because retail shopping involves a lot of things. Like you can have an AI agent just go ahead and order something for you on Amazon, because Amazon would have a product catalog. It has to click on that, insert your delivery, click on a lot of options, and then go check out. So that has multi-hop, multi-step actions, and the accuracy is way low because it is a really complicated thing for an AI agent to do that. Anyone could, even a kid could probably go ahead and shop on Amazon, but for an AI agent, it's not that easy because of so many function calls, right? So it's really inconsistent. So GPT-4o was able to do less than 25% of the times when you're using 8 trials. So, so this is one of the benchmarks that you could probably use to evaluate your AI agent. How well is it performing? And then create guardrails, or at least make it more efficient. It's almost like writing unit tests for your code. And there's one more evaluation. So this is basically called automated dynamic evaluation. So end of the day, it's what we're trying to do here is you're all actually measuring API invocation, and you're basically doing the exact thing. But what you're doing here in the Tau bench is you're creating a lot of user sessions, a lot of user data synthetically, and you're simulating dynamic conversations over here and measuring it if it is able to do it or not, and if it is able to succeed or not. And you're basically doing something similar here. Simulating real user to AI conversation, but it's a different research paper called AutoDE, or automated dynamic evaluation. But what you're using here is the limitation of Tau benches. Usually it has to be human who has to go ahead and check for all of this, but that is not scalable. Whereas here in this, it's automated. So it's usually the large language model only is evaluating. So it's not the human, but against an LLM that is evaluating. So imagine you have LLM that does a mistake, and now you have an LLM that again go and points out that there is a mistake. So that is what it is. So it's LLM-based user agent, and there's also a user script. So and how your agent has to, whether to check if it is aligned towards human conversation patterns or not. You can't have your agent just talk rudely to your customer who's just asking questions, right? It has to be aligned with customer your company's policies. Maybe if you're talking to a support agent. So basically, it identifies issues overlooked by static evaluations, and it also aligns with human assessment. And what we're doing is exact same here. Again, it's called LLM as a judge, and you would see this in a lot of tools like LangFuse, Langsmith. It basically what you're using is LLM as a judge, right? You have user input, you have LLM or your agent, which does a lot of things like tool call. It does retrieval. So Indrajit, or I think it was, I don't know who I was speaking to before, was talking about retrieval. So if you see agent, apart from tool call, could also be retrieval too, right? Tool call is you're going and calling some data or getting some data from, or retrieving some additional metadata from vector DB. That could also be retrieval. Retrieval could not be right all the time. Retrieval could go wrong because your desired data, the chunk, could probably be K10, which is like 10th chunk in the retrieval, which has to be first chunk, but it is somewhere in the 10th chunk. But how do you make it more efficient, right? But at least you should know that it is wrong, right? Because you have a data set, you want to check your RAG, you want to evaluate your RAG performance. And if it is taking really long time, maybe it is doing really well for couple of examples that you have, but if you simulate like a lot of examples, there could be some areas where retrieval could go wrong. There could be policies that you want to retrieve, and the document that you're trying to retrieve from has a data policy. It could also have a policy to enter a building. It could have a policy to for your HR. So there could be different policies in that document. So there is a very high chance the LLM could get confused and it could retrieve chunk that is very similar in the semantic world, but it might not. End of the day, right? But how are you judging that? So you could again use a different LLM to see whether that response is it accurate to what the customer or the user was asking or not, right? So that is again using LLM as a judge. Here you see the example, is it polite? Yes or no? I mean, you're just checking if that conclusion of the LLM, the response that it gave, is it polite or it's hard or rude? So you're just again evaluating it. It's more of a batch process that's happening after the LLM or the agent is done with the task. So same thing here. You're just evaluating it, seeing how is it performing, giving it a lot of examples. Tomorrow you can say, okay, my agent is like 80% accurate. It's not 100%, but it is there. And there's also something called plan bench. Okay, this plan bench is also from the paper. So what you're doing is basically you're creating a lot of scenarios for your agent to plan things out, right? Planning and reasoning could be very different for different agents. I mean, after a couple of slides, I think we have an example where we'll be going through a agent, which is a travel agent. We'll be going through different evaluation steps that will happen through every task. So agent could perform many tasks. Let's say if you have a travel agent, the travel agent could be doing your booking. It could be answering your customer queries, or it could also be performing updates to your specific query. So there could be a lot of different queries that your agent has to handle, right? If you just develop an agent that just do simple thing like, I have this agent that just goes and book the ticket. And it could only do that. It's very brittle agent design because your agent could only do that. It can't do beyond it. Let's say customer asks and say, can you go ahead and update my ticket? It would probably come back and say, no, it cannot. Because your agent design doesn't incorporate all of those. So how would you do it? Basically, you need to evaluate if your agent could actually do that or not. I mean, inherently agents could do proper planning, but whether you have to evaluate if your prompt or your way you craft or design your agent incorporates those use cases or not. How would you do that? By creating a planning benchmark. So what you do with this is you create different scenarios. You create different planning or reasoning paths. Let's say someone comes and updates, or they want to update the ticket. Now the planning has to be go ahead and check if the person previously booked or if that person actually has a booking or not. And then check when was it and check for the date when they want to arrive, if their existing flights available or not. And then, there's a complex workflow that the agent has to go through. The set of planning is different. So this has to be evaluated when you're actually releasing your agent in product. So you need to create a benchmark which has those scenarios and then evaluate your agent on that. So it will be more comprehensive evaluation. And you could apply this across different domains. And then you could check if the plan generation is apt, is it able to adapt to the changes, because your agent is supposed to do only the booking, but now there is a change of request, and whether it was able to do the proper function calling, whether it is able to do a proper chain of thoughts on how it has to resolve the problem. Right? So this is something that a planning benchmark has to be created, because the agents are not just there for doing some ad hoc task. Because if it is simple going ahead and creating a flight ticket, you could probably have a Python script that can do that as well, right? You don't need to have this agent. You could just have a script to do that. But what is an advantage with agents is they could be adaptive. They could be generalized to different scenarios. They have to get into anomalies. They have to recover from anomalies. They have to do a proper planning, just like how humans are doing, right? That is something that will definitely aid everyone to be more productive. That is the end goal for this. So plan bench really makes a lot of advantage. I mean, definitely add a lot of value there. What is self-reflect, right? Just like humans, we do a specific task. We might not be right 100% of the time. We might make mistake, but once you make a mistake, you just realize there's a mistake. And now you, again, given a same scenario, you would not make that mistake, because you should be able to know if that is a mistake or not. You should know exactly if there is a mistake that is done. And then you need to evaluate on it reiterate yourself on what was the issue or why did you make that mistake? Is it a knowledge debt or something like that? And once that update is done, then you could just go ahead and optimize yourself a bit more. I mean, just like how humans do, the same thing should happen with the AI agents. That would only happen by giving it different, maybe testing it out by giving like different one of the research papers does like mainly they do research by giving them different multiple choice questions and then ask questions on which is the right option, which is the wrong option. If it is wrong, then it has to reflect on the wrong answer. It has to explain why that is wrong, and then it will optimize itself and then come back and next time you ask it, it will probably give you a right answer. So it's basically analyzing the chain of thoughts for different errors, and it's just optimizing itself not to get into that initial error again. So it's basically over time, it is getting better and better over time. How is it doing it? It's basically self-reflecting it. Once it makes the mistake, it's just going and reflecting it. So let's say you ask your travel agent to do a specific operation. Maybe just go ahead and write a feedback to a customer or address a customer's complaint. It might write a proper feedback or proper response to that customer complaint, but it might not be right 100% of the time, right? In the first go, it might not be right. It has to go ahead and reiterate and check, did it make any mistake? Was it addressing all of the customer complaints or not? Is there any things that it ignored? Whether the response it has written is polite or not. It has to self-reflect. Oh, maybe there's something that is missing. Maybe it is not addressing all of the customers' complaint. Now it has to go back, self-reflect it, and rewrite it. And it also analyze like why it ignored that response. Maybe it ignored it because of some other deviating issues. It ignored it. Maybe it is not aware of that specific part of the customer complaint, or maybe it is not aware that is a complaint or not because it is lacking some domain knowledge. So it will explain it, and then it will just go add that additional context to itself, and then now write again a proper response. So it's basically self-reflecting it and creating more refined responses. That is what this self-reflection is all about. So it's analyzing chain of thought for errors, monitoring performance metrics, and it's implementing like feedback loop for continuous improvement. That's what it is doing. Self-reflection is really important for running all these evaluations for your AI agent, and it's always better to use this to make your agents more efficient. So yeah, I think these are different evaluations that might be needed. They could be a lot more, but end of the day, what you're trying to do is you're just simulating this agent, getting it, creating this environment for AI agent, and having it go through different scenarios, right? You can't just everyone could. I mean, developing an AI agent is very simple. It's just what I say is it's only 10% of the task. What takes a lot of your time is around evaluations and benchmarking. That takes a lot of time because these are undeterministic things. So you need to craft your prompt properly. You would update your prompts properly. You would collect the metrics. It has to be a data-driven development. Yeah, it is not as simple as writing a unit test because your unit test cases or your code is deterministic. Your code would actually work the similar way, but AI agents may not. They might definitely not work as it is. So you need to engineer it a lot. So building AI agent is only 10% of your work. What takes more time is to create benchmarking, to create evaluations. So I'll just go through a simple example from here, but which is handling and different tasks and some optimization. So there are a few more slides that we'll go through it, but it's a simple agent. I think as soon as we're done with this, we can go through the sessions, some question and answer. Or if you want to have any questions, you could all answer or ask me now. Maybe for a couple of minutes I can spare so that we can ask, because other slides are basically a same walkthrough of how we can run evaluations for this example agent. So it's not something, there's something that everyone can correlate with knowledge that you already have through the slides. Yeah, anyone?
Hi, Ralph.
Yeah.
I'm Rashekar.
Yeah, Rashekar.
So you are saying like booking a flight in that AI agents are helpful in this. So if you are booking any flight, means if you are using this AI agent, so is there any it will directly book the flight from the from the the destination and source we are given, and it will be booking the flight, or we need it's like the code, everything will be done by using the LLM, or we need some Java code or any other languages code.
So, okay, when you say the code, what code are you talking? Is it the agent code to book that source and destination? Or are you talking about the code to just go ahead and do that API calls?
Yeah,
What are you referring to?
I'm just like I'm a developer, so
Sure.
like I want to know
Mhm.
there is a code is already written where
Yes.
it is take the details from the website, and manually we are doing the code. We are writing, we are checking, we're giving the destination source, and also we are giving the booking details, and also the meals details. It is a which one, and preferably window seat. So everything we have taken the seat, and we are booking the flight ticket. So for
Yes.
that, there is some language is there, some
Yes.
Java is written,
Yes.
the
Yes.
database is there, so everything is written. So in this, if you take as AI agent you with LLMs, so where it will be helpful, it will write the code for the database layer, or it's in
Shut
the
the fuck up, fat
backup
lord.
layer,
Um,
or any other layer. So it
um,
will entirely replace the code.
so yeah, I mean, so here what happens is the code to to build this AI agent, it's usually, you could write it in Python, Java too. You can also use semantic kernel in Java to write this AI agent that does all of this coding. But if you just, let's say, you imagine without imagine you only wrote Java, right? Without any of this AI agent itself. You could still do that, right? In Java, you can
Yes, yes.
probably take source and destination, and
Can
you can
I
create
can
a
I add
function. And
something on this discussion, if you don't mind?
yes, Sanjit, yeah, go ahead.
Yeah, so what his question was, I understood. So
Yes.
normally, take an example of a use case searching, you want to book a flight. Okay, now the
Uh-huh.
way we are booking a flight using some website, make my trip
Mm-hmm.
yatra.com, or directly from the airline company website itself. So when you are going from a wave UI, actually make my trip yatra.com, these are all clients. It's not a backend server logic is there. So when I go for a search for a flight, source as destination, then we're giving the date. Then we'll click the button called search. Then it will give multiple flights based on the hops connection, direct flight,
Yes.
connected flight, domestic flight, international flights based on this all these things.
Yes.
We are giving the wave UI only, okay, make my trip. But
Yes.
behind the screen, there's a lot of server is running on. These are
Yes.
provided by the big companies like Sita, Amadeus Lab, Sabre Holdings. They have the reservation systems running behind the screen. They have a scheduling, they have a connectivity, they have a booking, cancellations, everything. Okay. Now,
Yes.
as far as my understanding, what AI agent is doing, will be not having any web interface or something like that. You will ask your applications in your this thing. Then you will ask, please give me a flight from this to this on that specific date. Okay. Of that,
Yes.
that query has gone to the then prompt engineering. They will pick up the specific keyword, source,
Mm-hmm.
destination, and date. Using that specific JSON payload will be created, and they will be invoking the REST API of that
Mm-hmm.
specific server, which is
Yes.
being called by the UI. Now,
Yes.
not ball. This is actually the backend server always will be the specific Amadeus lab code
Mm-hmm.
API. If they are exposing that one, you will give it a
Yes.
specific request from that one. They give it, and you will be giving back the response finally back. And again, you just parsing it that JSON data, and you will get the
Mm-hmm.
response back and display in your dashboard or whatever. It is a chatbot or something. It's like that. So AI agent, that is this is a kind of adapter, getting the data
Yes.
from the input and extract it, parsing it, get the exact word, which is not all the word is meaningful when you're typing it. Source, destination,
Yes.
and date is needed for this specific, and sometimes connecting flight explicitly we are talking about, and it will give all the response, multiple flights, and which one you want it. So I think that is one. The backend server flight reservations will not develop by the AI agent. That is there nothing but a API calling by the specific AI agent. This is my understanding what in the use case, I think so.
Yes, Ranjit, you're right on point. And that is a very good explanation about. I think that definitely answers your question, Rashikar. Whatever
Yeah,
you have.
thank you,
Yes,
Ranjit.
yeah. Thank you, Ranjit. Yeah, definitely. It's not. We're not. I mean, now they're code generators. They can definitely write that code, but we're not trusting that AI generated code in prod. So they are just there to help us to expedite the code, but not to write production grade code yet. So, but still, what we're doing, what Ranjit said is right. Anyhow, we could go into Make My Trip or anything and select different buttons to book a specific reservation for you. But now the UX changes. Now it's more of a chat interface where you can ask that to go ahead and perform the same action. But end of the day, the same JSON payload that is passed from the UI when you do your UI actions is actually done from the agent side, where it is actually sending the JSON payload directly to the backend, and then you're getting a response. And I mean, it's just one part of what AI agent could do, or the travel agent could do. Travel agent could do a lot more. This is one of the tasks that it could do. It could also answer customer queries. It could also change and update stuff, because now you want to go ahead and update your question and whatever it is, right? It will probably take a lot of time. And people who have disabilities, they cannot see the screen. Maybe elderly, they cannot see the screen. They can't do the booking. But tomorrow we could also have. I mean, now itself, AI agents are multimodal, so you can even talk to it and get things done. But end of the day, they are not perfect machines. I'm not saying these will just happen overnight, but still, you could make it 100%. You could make these systems more reliable by doing all these evaluations, right? So yeah, let me go ahead and give you the further.
One more
Yes.
question. Yeah, hello.
Yes.
This is
Yes.
Kadam here. I just want to know, trying to understand the AI agent. See, my question would be like, suppose AI agent, will it have all the algorithms like AI algorithms, machine learning algorithms, and neural network algorithms, and deep learning algorithms? Even some of them, will it be picking up, and all the algorithms will be included inside the AI agent is it a service or a as well? That's I'm trying to understand.
Yes. So
One
there are
more
two
thing
things.
I want to add.
Yes.
Hi, Raj.
Yes. Go ahead.
AI agent, is it a required sophisticated hardware like LLM models, or it just work like a software, means we can do it on normal systems?
I don't. I mean, let me first answer the first question, and then I'll probably get back to you on this. So first thing is, the first question that I got was, I'm sorry. The question was if whether this AI agents, ML algorithms, and all of these are working under the hood for these AI agents or not. That is one of the questions that I was get asked by. I think it was Murthy who asked me the
Yeah.
question. Yes, Murthy.
Right.
So yes, Murthy. So basically, when you talk about ML algorithms, right? ML is machine learning, right? So machine learning algorithms are basically the way this ML is trained is through data, and then you build a model with it, and your data is more a structured data, right? Your structured data could be tabular data, or it could also be some structured data, right? So then you build an ML model. ML model has maybe you have predictive analytics, you have ensemble models, you have different kind of algorithm that are already there, and then you have an output that comes in to predict something or to classify something, right? That could be something that your ML model is doing, right? So that is a different thing, because that is machine learning, and what we're dealing with LLMs or these large language models is something called deep learning. So what is deep learning? Deep learning is when ML is predefined features, right? ML, when you're running, okay, maybe you want to classify if the customer will leave your company or not, then you have some set of features, the customer name, age, and everything, and you just give it the input to it, and your model will say yes or no, right? Whereas the deep learning, the features are unlimited, right? The features are so huge, because deep learning is nothing but you can't directly differentiate the features, and also it is trained with large amount of data, where your deep learning model is basically detecting patterns and coming up with an output. And what LLMs are is, even beyond deep learning, they're also generative layer. So there is also generative layer, means you can generate content. You can understand, because the data here is not structured data like tabular data. The data here is unstructured data like a natural language, right? Natural language is very unstructured. You can say, okay, I'm going to a bank. You say, okay, I'm going to a bank. So what bank? Are you going to a river bank? Are you going to a blood bank? Are you going to a financial bank? So which bank, right? So it's very anomalies, right? Our language is very uncertain. That is the reason why the deep learning is a field which helped in building something called LLMs with transformer. Transformer is the basic architecture that we're using to build a generalist model like this, which is a large language model. And this large language model could actually understand human language and generate human language, right? That is the reason. And also they're not just generate human language, but they can also generate JSON functions, right? Because now you have a friend. I don't know if you're a developer, Murthy. Are you a developer, Murthy?
Yes, I'm a
Yeah, you're a developer.
Yes,
So you have
yes.
a front-end code and your back-end code, right? Your front-end code, you do different actions, and then you go submit. Your submit means you'll just go give a JSON workload. JSON payload is going and hitting your backend, right? If imagine now your agents are not just generating natural language, these LLM powered, this large language model code is not just generating natural language, but they're also generating code. They're also generating JSON. So instead of this model, instead of you have a UI that is going and when you do all these actions and click submit, which will send the JSON to your backend, now you have the agent itself, the LLM itself can directly generate that JSON. It can generate the JSON itself. You don't need to have a separate layer like a front end. It can just generate it on the fly, because it can generate a very undeterministic language like ours. Then it is easy for it to generate code or even like more structured based JSON. Hopefully I'm making sense here, right? So that is what LLM is. So machine learning is different. Yes. Deep learning is different. Deep learning and LLMs and all of it are a field in these models are developed with deep learning, with large, LLM. That is the reason they say large language model, because large actually refers with huge model with billions of parameters. The parameters in your machine learning model would probably be like, maybe, a few thousands or maybe, 10,000 to a million. But, this model has billions and trillions of parameters. Parameters are nothing but a blob of numbers. Okay. So that is what it is. So it's two different things.
Yeah.
Hopefully I answered that.
Continuation of that question. Suppose I want to build a generative AI or application like content generation. For that, do I need to use the AI agent third party, or is it okay to without AI agent? Is it better? I'm still trying to understand which way to proceed and why.
See, let's say you want to create content, right, Murthy? So let's say you want to content and you are say with agent or without agent. When you say without agent means you want to use ChatGPT, right? ChatGPT, is that what you mean? Maybe something like ChatGPT, or with what do you mean without?
ChatGPT may not be an agent, right? I thought like ChatGPT is like a LLM model, right?
Yeah, that is what I'm saying, right? I mean, I'm just trying to understand your question. When you say without, what do you mean by without?
My aim is how to create an application which will generate a content using this AI, right? So that way, what all ways I can do with the agent? Predefined, some people provide, right? Open source agent or AWS or any other agent. Do I need to use that, or is it okay to build my own without this agent?
No. I mean, it is always, because you can't build large language. There are also small language models that you can use, but it's always better to use open source or closed source. If you want to build something of your own, probably it would probably take a lot of money. Yeah, because these are not small ML models that you can build in a Jupyter notebook. These are large language model. Even a small language model at least requires like 800s, trained for like 8 hours or 5 hours, depending on how much data you have, how big is your corpus and everything. Yes. Okay. So I think I'll just want to go ahead with the complete this, and then I think we'll have the session. It's just the simple thing what I previously spoke. I'm just applying the same thing here. So yeah, end of the day, this agent is not just generating the JSON payload to emulate the UI actions, but also it is doing a lot more. So I'll be breaking down all of those tasks. Okay. Some tasks like flight booking, modifying reservation, canceling flights. There's a lot of things that we would probably have this agent do, and how are we evaluating? And this is the overall anatomy of how this AI agent looks like. You have a vector memory, because your vector DB to store your memory, because AI agent should remember, previous actions, what it did. So you need to have that. And you also have a planning engine that is again an LLM that does all of this planning. And you have tools interface, because once the planning is done, next comes the tools that will actually take different actions, right? Calling an external API or a database, right? This is how overall how your agent might look. And regarding the implementation, this could reside on Azure, AWS, or anywhere. You don't, and even LangGraph also has their own cloud. So implementation could be done across different languages too. You can use Java, Python, or whatever it is. I mean, LangGraph is one of the frameworks. .NET is also something I think people have in AutoGen that you can use. So yeah, there are a lot of frameworks to use. Different programming languages are there to build an agent. So even Llama Index is there. So this is a simple task, handling booking requests. So it's a very simple task, right? Whether if it can handle booking reservation from New York to Paris, and what are the challenges. Real-time flight data accessing is a challenge. And what are the fare rules or baggage allowance is a challenge. Ensuring system database reflects the final booking correctly. I think we already discussed something like this in the Tau bench, right? How do you do this evaluation? You basically create different user simulations of someone booking a flight, and then you access whether the database reflects that changes or not. So if your agent actually performed that action or not. Past metrics, again, evaluating if the consistency is there across similar bookings or not. Final state is check if the database actually reflects if that change is done or not. So you're basically validating if your agent actually performed the task or not. It was able to create that function. It was able to call the function. It was able to get the flight details, and also abiding all of this data through the airline fare rules and baggage allowance. So this is something that has to remember. This is all comes to that policy guidelines, guidelines that it has to remember. That is all part of the prompt or the system prompt, or the data that it can retrieve from maybe it's vector DB, right? That is where RAG comes into picture. If there's so much data, maybe there are like 10,000 PDFs, then it should at least know which PDF to extract to get that data, or that, that specific rule regarding bag allowance or anything like that, right? And the other one is resolving customer requests. Here also there could be a lot of requests that the customer would come up with. It would not be all ideal. Sometimes a customer actually booked the flight, but you want to reschedule. They want to also do not just reschedule, but also want to apply a voucher, avoid additional fees, and retain their baggage selection. So this is more complicated. And now, how would you evaluate these scenarios? By creating a planning benchmark, by creating different steps, by creating different workflows on how how to check eligibility vouchers, how to find alternate flights, how to apply relevant policies on fare changes. All of these, right, would require the model to also access a lot of data that is internal to that airlines. So that is where RAG also come into picture. So when you're evaluating this, you're actually also evaluating how the RAG performance is done, right? Because when it is evaluating and responding to your customer, it should not go ahead and give a wrong information to them, right? It has to give the right information. So I don't know, someone in begin, whenever, I think it was Aman, I guess. So when you ask this question, whether we are going to discuss RAG or not, yeah, under the hood, that is what we're trying to evaluate here. Under the hood, we're trying to evaluate if the model is able to extract the right policies and also retrieve the right airline fare rules, which could be part of a PDF probably ingested into some vector DB, right? So that is how it was able to resolve the customer request. And this is all part of this evaluation called plan bench. And you also have the other one is like responding to customer complaints. This is again, we already spoke about self-reflection. I think I gave the same example there. So you have to go ahead, create a response, and then self-correct, auto-correct it, make sure that it is already having all of the information. And also making sure that it is more empathic. The response is empathy based. You can't just be rude to your customer. So you need to have that handling of that emotionally charged interactions, analyzing different policies. So all of these would again come into this self-reflection. Could be one of the evaluation that we could probably do, where your LLM would probably self-reflect on how it is analyzing and then improve iteratively, like continuously it is improving. That should be part of your evaluation. And managing fraudulent requests is also really important, because there could be people coming and claiming that they already have a flight canceled, but they haven't got a refund, and they might fool the LLM. So it has to go ahead and look for inconsistencies. It has to go ahead and pull different databases, follow different policies on refund eligibility, avoid any over escalation. You can't just over escalate that as well, right? You should basically be more better. And the end of the day is again, evaluation could also include tool calling. Tool calling could be one of the evaluation here, because it has to go and talk to external systems. So a tool calling would be in order to accomplish this task, it should be evaluated on tool calling and also decision-making evaluation, whether it's making the right decision or not. Optimization of AI agents, right? This is what we evaluation is done. Optimization is just one slide. I just want to cover this. There could be a lot of optimizations that AI agents could go through. Prompt optimization, AI agent is actually crafted through a prompt. So you build using Java or you build using anything or, Python or any of the code. End of the day, the agent's personality is actually written in plain English. You're just telling, okay, you are an agent, you're trying to do this, you're a travel agent, this is your company, this is your company details, this is the function to call your company details, this is the function to go and book, this is the function to just go ahead and cancel or send an email to them. So you craft all of it. This is all prompt optimization. So first time, you can't immediately cover all of the use cases. You would able to optimize the prompt based on the evaluation. You do an evaluation, the tool calling is not working because you not explicitly mentioned it, or maybe it is not going ahead and getting some information from some database because you haven't created tool only for that, so you haven't given that access to your LLM, so it will hallucinate. So you should tell your prompt should include at least to educate, to give documentation to your agent. So the prompt would include all of it, right? The prompt optimization is a repetitive process. That is something when you optimize your prompt, you're optimizing your AI agent. A few short learning is, let's say, if you want to give a small, you can't expect this LLM to just go ahead and respond or perform a specific action immediately. You have to give some examples to it. Let's say you're trying to have it understand how to write an empathetic email, then, with empathy, so you could directly ask it to do it, or maybe you want to abide it to certain style that your company has, maybe certain style you already follow. So you can't have LLM already have that knowledge, right? What you do is you give some examples. Hey, this is how we write, or this is how our format of emails are. This is what the standard email is. So you give that few examples. Then what happens is the LLM, when it's generating, it will abide by that example to learn that in context only. So you're not training it, but you're just giving that as part of your prompt and having it learn that examples within that. I mean, yeah, I know your prompt could be really long, but there are some strategies to optimize that too. I think in the next line, which is prompt caching. So what you could do is, if the prompt is very long, and every time you're talking to your LLM provider like ChatGPT, you're sending this huge prompt that you developed to build your AI agent every time back and forth. So a lot of network latencies are there. They will be costing a lot because OpenAI will charge you per token. One token it could be one word or 1.5 word or even a half word. So it could be anything, right? You're paying for every token. So how do you save cost? There's something called prompt caching, where you tell your LLM, hey, just go cache all these prompts. There are few shots learning, some examples, everything I have, just cache it, so that you are not sending it every time to your network through your network. If any of all of your developers, you could definitely understand this, like just like how you're sending a request, like when you optimizing your database, you have a caching layer, which is basically caching the data, right? Same thing here. When you do this prompt caching, your LLM provider is actually caching that prompt, and you're just paying a minimal for that. You're not paying as much money as per token. You're just paying a discounted price. So that is what a prompt caching is. Continuous monitoring is always there because you need to monitor your agents. Yeah, we already discussed LLM as judge. So your LLM as judge will keep on monitoring it. If there is maybe your model start failing every time, or your model start generating emails which are really not which are rude, then your LLM as judge would tell, hey, this is something doing, your agent is like messing up. Then you should know that the continuous monitoring should be there. User feedback integration is also needed because user experience is what we care about. So that integration, that feedback is something that LLM could again read that feedback and understand if that even perform well or not, just like a human. And I mean, I'm talking about LLM doing all this, but the best strategy to have to develop a efficient AI agent is to have human in the loop. You can never trust these agents to do everything, but you can't just this agent just go and book the ticket, right? Because it can do a lot of mistakes. So you need to have human in the loop. It will just come back and say, hey, I'm booking the ticket from this to this. This is the date. This is the time. Can you confirm? If the human confirms, then it has to go and book it. So that human in the loop should always be there for these agents. These agents are autonomous. I mean, yeah, that's great, but you can't build a system saying that you just go do everything by yourself. Then, 100% of the time, at least it will only work 60 or 70 or 80% of the time. Even if you build like very great system, maximum like 80, 85%, but it might fail even after that, right? So you should able to make sure that human in the loop is always there. And fine tuning or SLM is nothing but a small language model. Oh, everyone loves OpenAI. We have GPT-4, very huge model. You have Llama is also a huge model, but the cost is really high. Let's say you want to build your own small language model, and fine tune it to do your own retrieval or to do your own stuff, then your cost is reduced drastically. You'll not be paying a lot more for a huge models. You'll be using small open source models. Like you see, like DeepSeek is a recent model that came out, which is it's actually beating Open AI O1 model, which just came out. So that is cheaper when compared with other one. So you could fine tune that model, or you could also use like small language model with LoRa's and QLoRa's. I mean, these are two things. I don't know how many of you, if you're not aware of these two, just ignore it. I mean, I might have a session on this maybe in February or March. We already had a session on this before, but yeah, fine tuning is one of the optimization for AI vision. And memory management is, anything that is doing, it has to memorize it, right? It has to previously, whether it did the booking or not. Previously, did the person who you're talking to, maybe you have an SRE agent, or maybe you have a developer agent which probably previously pushed some code to GitHub, and you should know whether that code that is pushed, was it done, whether the feature implementation is done or not, right? This agent should able to store that in a long-term memory, and that memory management is very important for this AI agent. You can optimize it by optimizing the memory layer. So yeah, I think we're almost done. Yeah, we are done. So questions and discussions, we have good half an hour. I think we can discuss it.
Can you go to the last slide, whatever you should?
Yes. Okay.
So coming to fine tuning in SLM for LoRa, low rank adaptation and quantized low rank adaptation. This is the
Yes.
normally fine tuning mechanisms we are doing in LLM models. Okay.
Yes.
Now, once we call the AI agent, multiple AI agents, because in our use case, not only one single AI agent, is the orchestration of AI agents will be there. So multiple AI agents will be getting data from multiple endpoints, maybe REST endpoints, and we will be getting the data. Those data will be storing in the vector DB. And once this in, then on the top of that LLM models or SLM model, we will do fine tuning. You're talking about that LoRa or quantized LoRa or something different?
Yes, I mean, fine tuning actually means you can, let's say you have let's say you use GPT-4. Let's say you're starting off with GPT-4 and you have a lot of responses to that GPT-4, right? You have the GPT-4 input and you have the output. You have input and output. You give a specific question, you get an output of response. You could use all the data to train a smaller model. You can fine tune that model with LoRa's. So you can have a LoRa adapter that can be fine tuned, and you can use that to use a small language model, and you can increase the accuracy or the evaluation benchmark of the small language model almost as equivalent as GPT-4. But the starting point should be GPT-4, so that it will give you all of the responses, and using that output to train the other one. It's called distillation. OpenAI also provide that distillation, or you could also fine tune it by using LoRa's and QLoRa's. That is how you would be doing it. I don't know if I answered your question. I mean, if not, can you please repeat that? But
yeah, fine. Fair enough.
Yeah.
So, but adding, hello,
Yes, Kamaljeet.
we'll be using, you said that for prompt optimization, we'll be having LLM. So again, fine tuning the SLM model, there'll be like two models here, right? We will also have LLM as well as SLM here.
Yes. I mean, you could optimize your AI agent because you could also you could have an SLM which is smaller and it is even more accurate than your main LLM. So it is a task that would happen over time. Yeah, they could be having two different things working parallelly. Because you are not just dealing with one LLM. There could be a bunch of LLMs that you'll be hitting and getting a response. But when you have, you could have it a parallel process, or you can start off with like 1-2 months of the data that you get. Then you can use that data to train your SLM and make it more optimized and better when compared with your LLM. So you're saving your cost, you're saving on your response time, and you are also saving on your, you're also you're saving costs. Your response time is reduced, and also you can self-host that SLM. So again, privacy is also assured, right? So yeah, definitely that is an additional burden for someone to do it, but the long-term benefits is really huge. So someone really using this a lot more, someone is maybe instead of spending a lot of money on LLMs. It's only when systems scale really high, right? That is when this will be applied, but not for anyone like, oh, maybe a small lab, or maybe, you're doing with a small traffic, then you only and you want the best response out and you want to hit GPT-4, don't want to compromise on any of this, then you could go with LLMs only. You don't need to go with SLM. But long-term SLM, there are also services which offer, called Predibase is one of the platform. OpenPipe is also one of the platform where they offer this service of distilling a small language model, make it more efficient and more cheaper than compared with an LLM. That is what they're offering.
Yeah, eventually, actually, we are
I
reducing
wanted
the rank of the matrix. Actually, when the LoRa, we are
Yes.
reducing the rank of the matrix. So
Yes.
because millions of parameter has been used to build the LLM model, so we are reducing the parameter. So that's why you are using actually LoRa technique or quantized LoRa techniques, so that less number of parameters will be there, so that it will be a small, large model actually. And
Yes.
is the SLM models available in some Hugging Face or some other places?
Yes, they're all available in Hugging Face. You can also get it from Microsoft. Yeah, Hugging Face or Microsoft, they all have SLMs. 5.2, 5.3 is a great model. 5.4 is also, I think, they came out. 5 is a model from Microsoft, the 5 series models. Mistral model, Mistral 7 billion parameter model. I think, yeah, there are a lot of models available already on Hugging Face, or even on, if you're using Databricks or Snowflake, even they have it.
Okay, thank you.
So also I wanted to ask, just confirm that for example, multiple agents, we are calling LLM multiple times here. If you are writing a code in Python, suppose if you are planning a trip somewhere, so booking agent is one, like finding the best place is one agent, finding the best food there is a one agent. So suppose I have a prompt to like book a trip to New Zealand with best food available. So LLM will be called multiple times here, right?
Yes, LLMs would be called multiple times, but when you say different agents for different LLMs, you could still use it. Maybe, let's say you want your agent, depending on the cognitive task, right? Let's say you're trying to book a flight ticket, right? It is just about generating a JSON payload. So it is not huge cognitive task, but you have a planning task. Let's say you have customer feedback, they are changing, updating your ticket and everything. That is huge task, which requires more robust planning, right? For that, you could have a bigger model like O1, or maybe a model like GPT-4o could be used. So it is always better to use multiple models depending on which task that you're trying to address, right? You could, depending on your cognitive workload, how huge of a task that you're trying to perform, you can hit that model. And especially SLMs could also be used for smaller tasks, like, oh, maybe you have a simple task where you have to just say if that is if the response that it is given is empathetic or not empathetic. It's a very simple classification task. You don't have to use GPT-4o model for that, right? Because a simple cognitive task is classifying it. So you could have an SLM do that task, right? So you could always use different models for your AI agents. That is based on, you can route your customer request, but that again, you have to create a layer in the beginning where you're routing your customer intent. So intent routing is something that you have to take care of in that case.
Okay. Thank
Yes.
you.
Yeah. Thank you.
Another thing is, let's say LLMs are like we have cloud things. And do you have SLM, any model or anything? Do you have? Are you aware of? If you let me know.
SLM. Yeah, there's Mistral. We had actually had a session on that SLMs before.
Okay.
I can type it. Mistral 7B is there. You have 5.3 models. 5.3 is like 3 billion, and Llama is also, you have 7 billion parameter model. Llama has a lot of 7 billion, and 1 billion also came. And Lava, DeepSeek also has SLM.
Sir, Kamakshi is trying to ask, where does data science play
Oh,
role in LLMs?
where does data science role?
Where does data science play a role in LLMs?
So, definitely, most of the agents, right? I mean, whatever you're trying to, because end of the day, these large language models, they are solving classification problem, right? You need to know exactly, whether your output that is gave the blue score, the output of LLM itself could actually be assessed by various models. Various data science models. The data science could be applied at multiple layers here. Okay, we're using that, or there are people actually building a data scientist with LLMs. I mean, yeah, you might be surprised. There are a lot of people, they say, oh, I want to be a data scientist, and these models are actually being a very good data scientists when compared with regular data scientists, because regular data scientists should have a domain knowledge, they should be able to have algorithms knowledge, they should have software engineering knowledge, and LLM has all of them. Only thing it lacks is your domain knowledge. What if you, as a data scientist, who already knows, I mean, LLMs cannot be used to build predictive models. Okay, that's not, it cannot be. But there are LLMs which are doing prediction a lot more better than regular data scientists. There was a recent paper which came up with where a financial reports, it read financial reports and it was able to predict what would be the financial performance of the company in the next year. What it did was just reading it. It read that. And also there were people who are using data science agents to optimize their backend GPU utilization. If you want to hire one data scientist outside, it's not easy. I mean, we already tried it. I'm not against hiring people. I mean, definitely it's not, you can't get a novel person to do or solve some problems, because you could get a data scientist with math background, but if you are asking him to work on computers optimizing backend infrastructure, it is really difficult. But what they did is they developed a data science agent that is optimizing GPUs, how GPUs are optimized, how the workload is distributed different GPUs, and how you can optimize it. And they were able to save a lot of millions of dollars now. They don't have to keep running a lot of GPUs. They were able to scale it down. They were able to distribute the load accurately by using a lot of data science techniques. And it is not a data scientist who applied all these techniques. It's actually an LLM AI agent that actually created equations, that actually created data science predictive models to predict the next workload and optimize the infra in such a way that the overall output is optimized. So most of the data science projects never get into product. I don't know if you're aware of it, Kamakshi, but they are just experimental products. There are a lot of failed products that companies have. What I see the future with data science is someone who want to pursue data science or who want to be a data scientist should have AI agent knowledge, so that they can build a data scientist AI agent which can work along with them and which can actually help them to make their project or build predictive models. I mean, predictive model building is a different ballgame. I mean, it's not LLMs cannot do it, but they are making these LLMs help them with doing multiple iterations, right? Imagine you have a group of 20 or 30 data scientists. You can create 20 or 30 different AI agents of data science, which would be doing data analysis and coming up with different conclusions. So you're rapidly doing that experimentation. You're doing that in a scalable manner, right? With appropriate cognition. So you'll be the best data scientist out there, right? A data scientist who's ignoring, no, LLMs is not my domain. Gen AI is not my domain. I don't care about it. I only build predictive models. Then, this domain is coming to just, definitely, make you jobless. So, I mean, I'm not being rude here, but that is the future which we are seeing, because all these papers coming every day is really, really questioning all these careers where people only think, okay, a data scientist is only supposed to build predictive models. So AI agents could encompass every area, every domain, a financial, a manager, anyone who's doing, I mean, I'm just giving travel agent example because it's a simple thing everyone could understand, but, it could also be a software engineer, a developer who could actually develop code, productionized code, create pipelines, deploy it into production, reiterate it. Maybe one developer doing the same task. Probably the AI agent could do a lot more better along with a different developer. AI agent standalone cannot do it because AI agent inherently have problems. But imagine a developer who can make use of an efficient data or AI agent could be way productive than someone who's actually working in Google or wherever. The best program. I mean, O1 model it was able to beat the best developers in the world. It's proven fact. They already have a benchmark. They already have SWE benchmark where people tasked it to develop some code and it was able to beat a lot of developers. So everyone has a developer in their pocket. The LLMs already have that cognition. It's only about using it and being more productive, right? People who do that would definitely keep going, and people who don't do it would be replaced. Definitely. I don't want to be rude here. I'm just saying that is the future. maybe 2-3 years from now, or maybe sooner?
Yeah.
So
Can
one
I
question on the
add something to this discussion?
can I proceed?
Yeah.
Yeah. See, one question on the, let's say to build a career, there are two categories I consider myself, like my own understanding. One is a data scientist coming to generative AI or whatever that field, and he'll do one data pipeline, data synthetic data sets, and data filtering, so many other things and so many metrics. He will do that. So this one category, the person who one category. Another category would be like a guy who's an engineer who's working on LLMs and maybe orchestrations and agentic frameworks or even optimization, something like that. So between these two category, what is the things you have to learn? Category one, category two.
See,
Who is the better to choose and when, why? I'm trying to understand that.
See, the thing here is what we are doing with building AI agents is simple API call. So Murthy, what programmer are you? I mean,
I am a
you're
Java and my microservice
yes,
programmer
you develop
on cloud.
yes,
Okay.
yeah,
Deployment.
you develop cloud native application. So
Correct.
when compared with a data scientist, I think you have better chance at building best AI agents. Only thing you have to do here is because you know how to deal with API layers, right? You know how to
Mm.
deal with how to programmatically, you know how to build stuff, you know exactly how to write code. So that is what needed when you want to build an AI agent. But only thing is your alignment on how you are doing things and you understanding the fundamental engine here, which is the LLM. What are the issues with the existing LLM? You don't have to go ahead and build a new LLM tomorrow. No one will ask you to do that. You should know how to
Right.
use this LLM to perform, to optimize, to automate a specific workflow, right? That is what you're trying to do, and that's what you're tasked to do, right? So I mean, we are coming up with a new platform called AINexus, a new program called AINexus for people like you, like who want to transition into building AI agents and all. So you can definitely be in touch with us. But what I'm saying is, person like you or people who are coming from software engineering background, it's easy for you to build AI agents. I did both. I mean, I was a deep learning researcher, so I did data side as well, and I'm also a DevOps and cloud engineer. I also wrote microservices. I do development and a lot of things as well. SRE, cloud engineering. I can write Java code too. So I'm a polyglot developer, and also I'm a data science and deep learning researcher too. So I come from both the spaces. So if you ask me who would be doing better at this, I would always say to build an AI agent I'm talking about. So I would always say someone coming with programming background could be easily tuned to building an AI agent. And optimizing it, fine tuning is also something that you could do. End of the day, what you're trying to do is you should possess maybe data engineering skills because you are trying to do something at scale. Let's say you're going ahead doing a huge enterprise, they have a lot of data, then you probably need some data engineering skills there, right? A data scientist would not have data engineering skills, and you as a developer can have data. I mean, should also at least know how to write functional coding, which I don't feel is really a huge task for you to do it. But that I'm talking about at scale, right? But if you want to build a simple AI agent using Java, maybe it is even better for you because you know how to wrap it in an API. But again, you should run evaluations. You should do proper benchmarking. You should know how to build your cognitive architecture. You should know how to access your tool, right? How much is the iterations? What is your budgeting, right? All of these are something that you have to. So you have to tune yourself to learn something in this space on how to build the AI agents, how to craft them, right? It's a different skill. It's more of reskilling. It's not something new. It's not rocket science, right? With AI, it's even easy for you to learn AI agents. I mean, it's not even rocket science. I can say, but someone coming with data science background, and someone only builds machine learning models, and they are not like they don't want to ignore data deep learning. It is really difficult for them because, and also one more thing is one more important thing. I mean, I know you build AI agents, but without domain knowledge, you cannot. So it's very important that you know the domain knowledge. What do you mean by domain knowledge? I mean, yeah, you are a developer. Maybe what is your domain? You could write code. Maybe you could solve your own domain problems using AI agent. Maybe you could have an AI agent which can write the best code, which can write best microservices with good code coverage, with less latencies, with good refresh time, whatever it is, right? With good health check, with proper logging and everything. And you could have your AI agent you solve your own domain problems. But let's say you're going and solving your domain problems of your business. You should know your business problems, right? But that is where the data science people shine because data science people know business problems. They know how they are solving a business issue, right? So
Right.
domain knowledge is more for a data scientist when compared with you. So you have more software engineering skills, and data science has more of domain knowledge. So both can get into AI agents development. But I mean, comparatively, being working with lot of data scientists, what I observe is most of our data scientists lack software engineering skills. I mean, they are good with math, they're good with Jupyter Notebook, but if I ask you to write them to write production code, they don't write. I mean, a lot of them, I mean, I'm not saying everyone, maybe a lot. I've seen many who don't, and I've seen a lot of software engineers who come and help them out to write production code. I mean, I worked as an ML ops, so I kind of glued between both. But yeah, I think both can be better at this building AI agents.
Yeah, that's a good answer. Another thing is like Vertex AI is from Google. So
Yes.
suppose Java with Vertex AI, I never worked on, but I just started more looking into that. They say it is very much LLM and other agents are developed in the Vertex AI. Can you highlight something or how bad Vertex AI can be used and where?
I mean, see, every cloud provider comes and say they have their own agent builders, right? Vertex is nothing but a different agent builder, and they also provide no code agent builder. So you don't even have to know how to write code, but at least in terms of node code, you can at least do some customizations, right? You can write some Java customizations to it, maybe an API or some kind of APIs that you can wrap it around. But you can go ahead and build stuff with us. It's not a huge deal. I mean, there's something called LangChain. Do you know JavaScript?
Mm-hmm. Yeah, right.
Yeah. So you could use LangChain with JavaScript. Even if you want to use Java backend, I mean, you could still do that. Maybe semantic kernel supports Java. So yeah, there are a lot of things. I mean, it's just about consuming API, Murthy. I mean, it's nothing more than that. Everyone says, okay, you can build an AI agent with their platform. It's just about you consuming their API to build it. By end of the day, as I said, right, what you would lack is the business problem. What business problem that you're trying to solve? What thing you're trying to solve? And also agent development is only 10%, as I said. What is 90% is your evaluation and benchmarking. And what is, and I'm not saying 90%, at least, 60 to 70%. And what 20% is the continuous iteration, continuous improvement, which happens over time every day, right? So this entire thing makes your agent to be in production and make it continuously optimized, right? That is what you need to. And this is not as a software development, you wrote your microservice, you deployed, and your microservice is working. Yeah, it is working all the time. Maybe once in a while it is, what happening is behavior changed. Maybe memory shoot up, or maybe your API, your dependent API is not there, your circuit breaker triggered, and your sidecar just snapped, and your API throw 503 or whatever error, like 400 error, whatever error is it, right? And that is once in a while you get into protocol. But imagine AI agent is not like that. It's very undeterministic. It's like some person working and running there. He can do a lot of mistakes, and you should always keep an eye on him, right? That is what AI agents is. It's a different ball game altogether. It's not like writing your microservices. It's even, it requires more work than that, but the benefits are really huge.
Okay. And let's say another thing is SLM or LLM in the market. How is the trend? Is it more SLM is utilized and customers are working on it, or LLM?
See, SLM, there are different things. I mean, people who are really already scaled a lot, and they would probably go with SLMs. And there are also some new category of people, like, when you talk about robotics, right? You want robotics or edge AI deployment. Edge AI means, you might have your phone. Now, Apple 16 has a 3 billion parameter model deployed on it. To do every small task, there are low res and QROS that are already running on your phone, which is Apple phone. So these models will be deployed on smaller devices. For them, SLMs are really needed. SLMs could go into different, maybe it will be sitting in your Samsung, or maybe it will be coming to your kids' toys as well tomorrow. You'll be sitting there and answering questions or explaining stuff to them. It will also be deployed in your car. So SLMs are definitely there for edge deployment. And robotics too. So the use case could be different. So SLMs are actually made for smaller resource constrained deployments, but they can also be used in production as well, depending on what is your cognitive task. Either you're trying to plan things out, then SLMs are not great at planning, because they can't go very deep planning. They can only do superficial, above and above. But you want to go very high, deeper level planning, LLM is definitely needed, like something like Oven, or maybe O model.
Okay. Okay, make it sounds good. Some basic understanding. Thank you.
Raj, I have two
Yeah.
things. Can you just tell me about the adaptive RAG, which is actually the strategy of RAG that is including two things: query analysis and self-corrective of RAG. Can you just put some highlight on which is actually superset of agentic AI RAG actually? So can you just put some highlights on adaptive RAG and the AGI, which is the future trend, artificial general intelligence? Can you just put some points on these things, jargons?
Sure. Yeah, so basically, adaptive RAG is, first thing is, when you build a vanilla RAG, right? What vanilla RAG does is it just goes in there, you give a question, it will give you the answer then and then, right? It retrieves every query that you give. It usually goes in there and gets you the response. And, it is not aware if that chunk of response is right or wrong. It just goes retrieves it because what it is doing is math, right? It's just comparing that with cosine similarities within your vector DB and just retrieving the chunk which is similar. And
Exactly.
there could be a lot of mistakes with that, right? You could have, as I said, I gave an example before, it could take a policy for maybe a building and confuse that with a policy to data or something like that. So adaptive RAG, it basically, it gives different, based on the question, it actually gives it will adapt. I mean, as I said previously, also one more pattern which I discussed was when you ask a question based on the cognitive workload, you have different models that you can use, right? You can use a smaller model, a bigger model, something like that. So adaptive RAG, what it does is analyzes the query that you are asking. It sees what kind of processing it has to do, whether it has to go ahead and answer it straight away, or it has to iteratively do the retrieval. Iteratively means it just goes get the question and then it will ask a question: is this a right retrieval or not? And then it will go back and again do a retrieval. Oh, all 10 retrievers or 10 chunks it has, which could be the right chunk that can answer this question. And then it will just go ahead and get that chunk and then it will give the response. So you're basically adding a one more layer which will self-reflect. You already have aware of the self-reflect pattern that we discussed here, right? So it's the same self-reflect pattern is asking and just going and said, okay, this is the thought, I think this is the answer. And you say, okay, this might not be the right answer. It'll just go and correct it and come back and give you the right answer. So this is what happening. So you could either have single shot retrieval, multi-shot retrieval, iterative retrieval for different questions, and dynamically adjust the retrieval strategy based on the input context. So that is what this adaptive RAG is. It's again agentic. It's the same pattern that you're applying there.
So the different framework, LangChain, they have the already inbuilt libraries available for adaptive RAG.
Yes, I mean you could use that already with LangChain or LangGraph, and it's just about you adding like few more lines of code and like having it. Yeah, just adding some more line. Only issue is latency. Only issue is the latency, right? Ranjit, you're getting more latencies here now. Your agent is again thinking a bit and then answering it, right? The two kind of thinking. I say, okay, can you go ahead and produce the best essay?
Just
right now,
one layer of wrapper we have to write on the top
yes.
of the
Yes. And more loop. It's just about loops. Like how are you looping?
Iteratively, we'll have to loop the queries and we'll have to get the response from the query. Based on that, we'll have to take a decision.
Yes. For complex questions, it is taking more time. And for simple questions, it is giving you the answer then and there. It's just like how O1, I don't know if you have worked with or at least used O1 model. It just syncs. It's called system 2 thinking. For complex questions, you're not immediately answering it. You're just thinking for a while and then answering that question. That is what system 2 thinking is. And that's what's happening here with adapting RAG.
Yeah, now the next is the future is the ultimate is the AGI. So can you just put on something on the artificial general intelligence?
So basically, people say, Sam Altman, I think he just confirmed that AGI will be achieved by next year, and no one would be really that surprised. I mean, I definitely feel that's right. I mean, what is AGI? AGI, end of the day, is, with O3 model, people are saying it's almost near AGI. Yeah, definitely it can do that, but these models which are coming up with more reasoning, right? They're doing planning. They're not answering straight away. If you see O1 model or O3 model, O3 model can solve a lot of questions, almost 80%. Of, I think 50 to 60% of questions in AGI benchmark, which is telling that it can do a lot of it can definitely answer that question. But when you ask it how much time it took and how much money it took, people say it took like $100,000 and it took like 18 hours to answer it, to solve that big problem, right? Can we say AGI is achieved? Yeah, maybe, almost we are 30, 70% there.